start the recording. Yesterday we talked about properties of exponents, how we had to subtract exponents sometimes we had to multiply exponents, reverse distributive property kind of situation there, reciprocal is going on there when you have a negative exponent. Now we're going to keep going with that philosophy, and we're going to move on to types of exponents that are actually not whole numbers. They're not even natural numbers. They're radicals. The rational numbers. They're fractions. And so we're going to see how a fraction exponent would relate to what we know already. Okay, so we should be able to finish up this section 1, 2. If I remember right, I only printed off pages 9 through 11. So there's only 3 pages. If this is a short lesson, then so be it. We'll just go with the short lesson today, and then we'll knock it out. Okay, everybody knows what the square root of 25 is, but you're supposed to know that the square root of 25 is not just 5, it's plus or minus 5. So make sure that you understand that first. All right, now let's read. So that's going to affect some of the things we do today. All right, so today we will review the meaning of the nth roots and converting expressions between exponential and radical form. All right, radical form would look like this. Exponential form would look like this. Okay, so you see that? So there's where the ideas kind of come from today. And also, the top of our numerator is always going to be 1, and well, for a while it's going to be 1. Sometimes it could be something else, and we'll talk about what happens then. All right, so consider the following expressions. We have the square root of 25, we have the cube root of negative 27, and then we have the nth root of a, and that equals b, and we'll talk about what that means. It's kind of a generic form. So what number can be squared to obtain 5? Well, 25, I'm sorry. So plus or minus 5 equals the square root of 25. In other words, 5 squared plus or minus 5 squared equals 25. So that's kind of the idea. Now, what I'm going to do for a while is to keep the confusion down is I'm going to take out this section and we're just going to deal with what we know, okay? In this case right here, we've got a cube root. So what number can be cubed in order to obtain negative 27? Well, if you take, obviously, if you take 3 negatives like that and multiply the negative 1, negative 1, negative 1, just like that, if you multiply all those together, you get a negative, right? But if you multiply 3 by itself 3 times, also, you get negative 20, or you get 27. But if you put the negative, each negative with each 3 here, you find out that negative 3 times negative 3 times negative 3 multiplies together to get negative 27. So negative 3 squared, cubed, equals negative 27. Now, here's the deal. Plus or minus is not going to work in this situation because the only answer you can get here is negative 3. You can't put positive 3 squared and get negative 27. That's not going to happen, okay? So in this case, there is no plus or minus sign. In this case, there is. All right, so if you were to write out this answer, the cube root of negative 27, I know you're thinking, wait, there's a negative under the radical. Is that going to be imaginary? Is there going to be an I involved here? No, there's actually not, because what happens is you're getting the cube root of a negative, and like I said, you can actually multiply 3 negatives by each other, and the cube root of negative 1 is negative 1. I can prove that to you with the calculator. Let's do that now. So second mode clear. All right, and then we're going to do the cube root of negative 1. Now I'm going to do this in two ways. I'm trying to remember how to do it both ways. So we've got, I'm going to start off with negative 3 in parentheses, and I'm going to put this in exponential form, okay? So a cube root is the same thing as putting something over, raising something to the 1/3 power, the 1/3 power. So I know that sounds crazy, but that's a cube root, okay? So let me zoom that in. And then when I hit enter, oh, I messed up. I was supposed to put the cube root of, that's the cube root of 3. So let's go back and put the cube root of -27, my bad. So we're going to go raise it to the 1/3 power, and you see how we get -3. Now, just to prove it to you, the cube root of -1 is going to be 1 divided, or raised to the 1 divided. So the cube root of -1 is -1. That should settle the issue here. Okay. So there is only one answer here, and it's -3. Okay, and that's it. This one had 2 answers. This one had 1 answer. All right, now let's go over here and talk about something raised to the 1/n power. You see that right there? So something raised to the 1/n power, or in other words, the nth root of something, equals b. And we're going to come out with, when b is raised to the nth power, when you, like, okay, if you were to come over here and say, if this was equal to x, and you were supposed to raise the x to the 2nd power. See, there's an imaginary 2 right there, right? It's a hidden 2. It's really, a square root is actually raising something to the 1/2 power. But what this is saying is when b is raised to the nth power, or when x is raised to the 2nd power, the result is a. The result is 25, okay? So if I were to square both sides, if I raise the x to the 2nd power, I get, you see that? 25, all right? So if I square both sides like that, the squares can't, and the square root cancel out. That's why these 2's go away, okay? And you're left with 25. So that's kind of what's happening here, is if I take, that's the nth root. So if I raise that to the nth power and raise b to the nth power, what happens is the nth root and the nth power cancel each other out, and then we find out what a's answer is. A would be b to the nth power. Okay, so I'm going to put a equals b to the nth power. All right, so I know these are kind of tough notes to follow, but you'll understand it as we go more. You'll start getting to where you can actually understand the material a little bit. So here's the nth root of a. That's the way I'm going to say that, the nth root of a. For n, an integer greater than 1, and all real numbers, a, we can represent in this format. So in other words, it's the n needs to be an integer, even though the exponent is going to be a fraction. That denominator down here is going to actually be a countable number, something that you can, a negative or a positive number. And yes, you can have a negative exponent. All right, so, and remember we talked about when you have a negative exponent, you basically flip the fraction upside down. You use reciprocal. We'll get into more of that later. All right, so we've got a is less than 0. So what if a is less than 0? What if it's negative, in other words? If a is less than 0 in this situation, if it was -25, then you would wind up with an imaginary answer, okay? If, in this case, a is less than 0, and it wound up with a real answer. So let's go over here and look at this. So here's a square root of -8. So n is an even integer, no real nth roots. All right. So you have the square root of -8. So what's going to happen here is, so let's set a letter over here. Let's call this b. Okay, just for now. And I want you to understand that there is a 2 right there. Okay. And when I square both sides, when I do the nth root of the nth exponent of both sides, I find out that b squared is equal to -8. Well, that's kind of what's happening here. So something squared is equal to -8. So if you were to go backwards and look at the problem again, you would you could also separate it out like this. So you could do the square root of -1 and the square root of 8. Well, the square root of -1 is I. The square root of -8 simplifies out to 4 times 2, which the square root of 4 is 2. So it's 2I square root of 2. So this is the answer that you should actually come up with when you have the square root of -8. All right? So a little bit complicated there. In this situation, it's not complicated. It's the cube root of 8. So if I were to put a b here and then raise this to the third power here, I would wind up canceling out the situation there, and I would notice that b to the third power equals -8. Well, if you go back and separate out -8, the square root of -8, you could separate it out into, I'm sorry, this is cube root, not square root, my bad. So you could separate it out into the cube root of -2 times -2 times -2. So 8 times 8 times 8 is, so 2 times 2 times 2 is 8. Negative times negative times negative equals negative. So that is equivalent to that. And what happens here is you can rewrite that -2 on the underneath the radical to the third power, and you can see how this cancels out here. And so we have -2 for my answer here. That's a little more understandable here than this is. Okay, a little bit of a hat trick on that. So what if a is equal to 0? What if something square rooted is equal to 0 here? Oh, by the way, this has no real nth roots, and that's why. Because it's imaginary. And then you have one real nth root, and then it's -2. I'm just showing you what's happening here, okay? And so one real nth root here, the square root of 0, I don't care how many times. Like if I were to put the 12th, if I were to multiply 0 by itself 12 times, it would still be 0, right? So what happens is this 12 and this 12th root cancel out, and the answer is going to be 0. Okay, pretty simple there. Both sets have one real nth root, so same situation here. So you could say the 9th root of 0 to the 9th power. 0 to the 9th power is just 0. I'm just rewriting that in kind of a smart way in order to find the answer. Okay, remember how you can multiply things by 1 and it doesn't change it? Well, you can keep multiplying 0 by 0 and it still doesn't change the answer. We're just using math in a kind of more of an intelligent way. All right, so we got a is greater than 0 here. What if this is positive? I mean, what if it was 1, 2, 3, 4? Okay. What about 16? Okay, the fourth root of 16. If we rewrite the fourth root of 16, we'd see that 2 times 2 times 2 times 2 equals 16, right? So we got 4 times 4 is 16. And then if we rewrite this in this format here, 2 to the 4th power, you can see how the 4th and the 4th root cancel each other out. Now, just a little side note here, why would they cancel each other out? So if I had this situation here, and then remember how this said a to the nth root of a is equal to a to the 1 over n. So this is the 4th root of this thing right here, okay? So if this is the 4th root of this, I'm going to raise it to the 1 over 4 power. So I'm going to raise this whole thing to the 1 over 4 power. And this goes back to what we learned yesterday, which is kind of the multiplication of it. So you would multiply the exponents. And if you'll notice that 1 is the reciprocal of the other. So we have 4 over 1 and 1 over 4. And what happens is you get a cancellation here. And so this would equal an even 2, right? So that's what's going to happen here. The 4th root of 16 is 2. And I'm going to prove that to you on the calculator. So I'm going to go over here and do the 4th root of 16. Okay, and now the 4th root, not 16 to the 4th power, it's 16 to the 1/4 power, okay? And that equals 2, okay? Let's look at this last one here. So we had one real nth root here. We're going to have one real nth root here, okay? Same situation here, same exact situation actually. 32 is equal 2 to the 5th power. So you could just basically take what you had here, multiply it by another 2, and then you notice that it's 5 2's stretched out. Well, what happens is these 2's cancel, these 5's cancel out same way here, because one is the reciprocal of the other. So the answer would be 2 again, okay? All right, so now I'm going to leave that up here for just a second to give you a chance to kind of finish writing down what. So are there any questions so far? I mean, I know it's so complicated, it's hard to come up with any questions, but if you can think of a question, just type it in the chat down there and I'll answer it as you go. Like, hey, Mr. King, go back, I need this, or something like that, okay? So we're on the second page out of 3. There's only 3 pages today. And so let's go and figure out what we're going to do. But look how complex this looks. It's really not that complicated, okay? So it's really simple. It's just a matter of you understanding what this M is, what this N is, what's going on with this negative situation. This is really, they're trying to throw everything at you, the whole kitchen sink at you, okay? So in other words, if I rewrote this, I'm going to kind of set you up for success here in just a second. So if you'll look at this, I can raise this to the 1th power underneath the radical. Now you can see how I can make this a fraction of 1 over 3. So I could rewrite this as the exponential form would be negative 64 to the 3rd power. Well, I mean, you could type it in the calculator exactly like this, but it's best, I think, to look at it in terms of the prime factorization. And so we've got, let's just start making a prime factorization situation going on here, okay? So we're going to have 2. Now I'm going to keep multiplying 2 until I can get to 64. It won't take long. All right, so I'm going to keep multiplying. Now, if you'll notice, I've got the negative here. I'm going to leave that negative for just a second. Oh, wait, okay, so now notice there's 3 numbers that we need. So, okay, let's go up here and do scratch work. I'm going to try and be a little smarter about this, okay? So the answer is going to be 4. 4 times 4 times 4, okay? Because 4 to the 3rd power is 64. 16 times 4 is 64. All right. And I'll show you on the calculator. 16 raised to 4 to the 3rd power is 64. See that? So there's 3 4s make a 64 when you multiply them together. So I need to be a little more clear on this. Now, what's fixing to happen is because of this negative situation, you can multiply negative by negative by negative and come out to be negative underneath the radical still. 64 is 4 times 4 times 4. So what really is happening here, I'm going to come down here and rewrite this. The 3rd root of negative 4 to the 3rd power cancels out. So this is negative 4 to the 3rd power. That cancels out. And so the answer to this problem right here, the cube root of negative 64 is negative 4. And I'm going to show you how to type that in here. So parentheses, negative 64 raised to the 1 over 3 power. Okay, and so you get negative 4 there, right? Now, what's going to be very interesting is when you get to Algebra 3, if any of y'all take Algebra 3 next semester or next year, you're going to notice that since I've covered this, if you take the time to actually kind of grasp this concept, you're going to be so much more ahead of everybody in the classroom, okay? Not many people understand this topic, and you're going to be the one sitting there, hey, no, you do it like this, right? You're going to tell them, you're going to be the one showing them how to do stuff. You know, if the teacher makes a mistake on the board, like I do sometimes, call them out on it. Hey, Mr. King, you were supposed to put a negative there. Then that way I know and you know that you understand the material. That's why I like you guys calling me out on my mistakes sometimes, because that helps me understand that you know what's going on and you're alert enough to Now we've got a situation here, okay? So you see how I've got a negative 64 here and it's squared? So what I'm going to do is I'm going to leave, obviously a negative is, I'm going to pull that out, and 64 is 8 times 8, right? So if I rewrite this as 2 square root of negative 8 squared, so it's negative parentheses 8 squared. The negative is not going to be squared here. So that's going to be a problem because we've got 2, the square root of 2 equals negative, or the square root of negative 1 times 8 squared, okay? And so what happens here is this square and this square root cancel each other out, but this is still the square root of negative 1. And you should know what the square root of negative 1 is now. So I'm going to pull out my 8, and then I'm going to pull out the I, and we have one real root. One imaginary root. See, I already made a mistake. So let's go over here and split this up. What you're going to do here, I don't know if you can see this very clearly, but I'm going to split this into the square root of negative 1 over the square root of negative, I keep talking, the square root of 1 and the square root of 64. And what's going to happen here, obviously, you know that there's the square root of 64 is, let's write this down here. The square root of 64 can be both positive and negative 8, and the square root of negative 1 can be both positive and negative 1. So these don't cancel here, okay? I'm just showing you that it's your answer would be, you could have two separate answers here. So it's going to be positive or negative 1 over 8. And so that's the answer. You know, now to prove that to you, so we could have 1 over 8 times 1 over 8. No, those are both positive, and so that gives me the square root of 1 over 64. And then the next one would be negative 1 over 8 times negative 1 over 8 square rooted. Okay, and then that gives me the square root of positive 1 over 64 because it's two negatives. You see that? So we do still have two answers. It's not like these symbols cancel or anything. All right, just splitting it up for you so you can see what's going on. All right, so negative cube root of 64, same situation. You know the answer is going to have a 4 in it somewhere because 4 times 4 times 4 is 64. We proved that up here. So we're going to put this negative out in front. That's not going to change. And then we're going to put the cube root of 64. Now, what's going to happen here is we're going to have a cube root of 4 times 4 times 4. So rewriting that, we get the cube root of 4 to the third power. And then the third power and the 3 cancel out there. The negative still stays, and it's going to be 4 for my final answer, okay? Negative 4. So I have one real root for that, only one. All right, now you can see why we only have 3 pages today. It's pretty advanced, right? Oh, do y'all know what, look at this. Can you tell me what number is supposed to go right here? It's imaginary. I'm going to leave this one blank for a minute. And I want to come over here for just a second and finish out because this looks very similar and these two kind of match up. So let's spread this apart here and we get, okay, so here's a problem. I think the best way to handle this problem is because we've got a negative here, let's spread this all out here. So we're going to, instead of doing it like I did here, we're going to spread this out into negative 1/4 times negative 1/4 times negative 1/4. So when you multiply 3 negatives together, you still get a negative underneath the radical. 4 times 4 times 4 is 64. 1 times 1 times 1 is 1. So all this makes negative 1 over 64 underneath the radical. I'm kind of forgetting what's over here. I'm trying to wash that out of my memory for right now, okay? So But if I rewrite this -1/4 to the third power, you can see now how these things cancel, because what happens? What's really going on here? If I wrote this in exponential form, I would see that we have -1/4 to the 3/3 power. See that? 3/3? And so 3/3 is 1. So that's why it cancels out. Okay. And anything to the 1 power is itself. Okay. So the answer is negative, -1/4. So that's going to be a +1/4 for the answer. So this turns out to be this. Let's prove it on the calculator. Okay. Let's come over here and type it out. Click on second mode clear. And I'm going to put negative first. I'm not going to mess with the negative. And then I'm going to put the parentheses, and I'm going to put -1/64 underneath the parentheses. And then I'm going to raise that to the what? I'm going to raise that to the, now there is no exponent under here. So I'm going to raise it to the 1/3 power. 1/3 power. And then I get 0.25, but I'm going to show you a little trick here. I think I might be able to show you a little trick. If you ever have a fraction, decimal value, and it can be turned into a fraction like this, just remember, what is it? Second, math, enter. Look at that. So let me show you that again. If you have a TI-84 and you have a decimal value, you push second, math, enter. Second, math, enter. And then you get a decimal converted to a fraction there. And then it's 1/4. Okay, so now let's move on. I hope we get to finish this today. All right, so how am I going to rewrite this? Now I'm going to rewrite this first one without explaining this. I just want you to see what's happening here, okay? I'll go back and explain this in a minute, but just watch this down here at the bottom. I'm going to convert the following expression with rational exponents to radical form, then evaluate. So what I'm going to do is I'm going to notice that I've got 2/3. So that must mean I must have a cube root situation. Okay, you see that? That's a cube root. But what is it a cube root of? It's a cube root of 125, obviously, so it's going to go underneath the radical. But what about this 2 here? This 2 is nothing more than just squaring what's under the radical. So if you were to rewrite this whole thing, you could say 125 to the 2/3 power. See that? Okay, so that's kind of what's happening here. It's a much more simplistic version of what this is saying, but because there's so many letters and numbers going on here, but converting between exponential and radical form, we can write expressions with rational exponents in either radical or exponential form. A to the m/n is equal to a to the 1/n to the m power. So in other words, the m is brought out. So if it's 1/n, then that's going to be the nth root of a. But it's the nth root of a to the m power because a is raised to the m power as well, okay? So in this case, we have the nth root of a to the m power. You could write it out like they're saying here. Let me see if I'm right here. All right. So what they're saying here is this, and I don't think I agree with that. Let's see if I can. So they're saying this, okay? All right. So to be honest, I haven't messed with this enough. I mean, I have, but I haven't messed with this enough to really have used it in this format. But I usually use it here and just try to figure it out. But anyway, we'll go with what they're saying here. So what we've got here, matter of fact, let's prove that real quick. Let's look at this. So second mode clear, let's put in, we're going to put in, all right, I got to figure out now how to do the cube root of something on this calculator. It's going to take me just a second to remember. Oh yeah, I think it's under math. And then, yeah, okay, so we got cube root there. So on this calculator, we can do a cube root of parentheses 125 and then square the 125 and then hit enter. We get 25, right? All right, let's see if this works. Fingers crossed. All right, so we're going to push parentheses and then what was it? Math, go down, hit enter, and then I get 125 under the radical outside of the, what I need to do is get outside of the, there we go. Now I'm outside of the radical and I'm going to put a square there. All right. Ooh, it worked. So it is true. Okay, so now let's go over here and figure it out. So let's keep following that format and let's figure out what's going on here with this negative situation. We have a negative square root and then let's clear it up. And then so we've got 8 to the negative 4/3 power. All right, so let's see what this means. That's going to be 8 to the, okay, 1/3 power. We can look at it like that. And then raised to the -4, all right? So in this situation here, we have a cube root of 8. That's what this means, the cube root of 8, all raised to the, you could write it in 2 ways. You can write it like this, or you can write it like this. It's better, I think, in this situation to write it like this because we can see now that we're going to have to use a reciprocal concept here. So, so instead of this to the 4th power or negative 4th power, it's going to be 1 over that to the positive 4th power. So see how it was on top of the fraction here. If you put a 1 underneath it, now it's a reciprocal. If we flip it upside down and put a 1 on top and then that on the bottom, you change the sign on that exponent there, okay? So what's going on here? Why is this the cube root of 8 to the, okay, so if I were to stop right there, I think I would, you know, this is actually answerable. So what I'm going to do is I'm going to keep going with it. To be honest, I don't like how there's a fraction. I mean, every mathematician on the planet would say you should not have a radical underneath on the denominator. It should be a real number, some kind of, not a real number. It should be an integer of some sort. Okay, so now let's uncomplicate things here. So the 8 is 2 times 2 times 2, all raised to the 4th power. And I'm going to keep going down here. So we're going to go 1 over the cube root of 2 to the 3rd power. So that's 3 2's multiplied together. So that's 3rd power. This goes away. And we have that 4 on the bottom down there. And so what does this mean? This is going to be 1 over 2 because this goes away. The 3 divided by 3 is 1, right? And then it's still raised to the 4th power. So it's 2 to the 4th power. And so my final answer is 1 over 16. And so that's how that works. Now you can prove that with a calculator, but I just want you to kind of see how this turns into this, okay, using the rules from above. So what we did was we split 4 over 3 into 4 times 1 over 3, or negative 4 times 1 over 3. And then we got the cube root of 8. The cube root of 8 is 2. That's down here. That's something you really should memorize, to be honest. Things like this, you really should just say, you should get to the point in the future to save yourself a lot of this writing. Just say 8 to the 3rd. The cube root of 8 is 2. Memorize it. You're going to need it, okay? You're going to see it over and over again. Just kind of get to the point where you can just know what you're talking about. All right, so in this case right here, so we're going to rewrite this a little bit more cleanly than this. So we're going to follow, okay, so first off, I need you to notice that the negative is going to stay out in front and it's not going to change. The negative is not what's being squared here. The negative is just your negative. What is being squared is the 32, all right? But if you write it out like they're explaining up above, what I would do is I would say 32 to the 1 over 5 and then doubled, or squared, I'm sorry. So it's if you multiply these two exponents here together, you get 2/5. You see that? So that goes back to that rule from yesterday. So now you should be able to tell that the 5th root of 32 is going to turn out to be something neat and easy. So there's that, okay? And what's the 5th root of 32? Okay, so let's go. Let's try 2 times 2 times 2 times 2 times 2. All right, remember 2 times 2 times 2 is 8, and then times 4 is 32. So 5 2's multiplied out like that equals 2 to the 5th power, and it's all raised to the 2nd power. This is a little bit cleaner than that is up there, but anyway, you could probably cut out a couple of steps. All right, so remember, it's not squaring the negative, it's only squaring what's inside of this parentheses. So the answer is -4, okay? All right, so now we're gonna wrap up today with the last page. We may have to cover the last page a little bit more tomorrow. I thought we were gonna be able to finish the whole thing today, but oh my goodness, it's taking a long time to explain this. All right, so we're going to do maybe one more problem, and then it's going to cut me off, and then we'll move on, okay? So let's convert the following expressions with rational exponent, that's fraction, that's a over b, fractions, okay? So to radical form, which is a to the b power, or the root of a. Basically, that's kind of what's happening. We're going to go from here to here. All right, so rational exponents to radical. So anyway, let's get into this. Let's finish this up. So converting, we're going to say 81 to the 1 over 4, all raised to the 3 power. So 3 times 1 over 4 is 3/4, okay? And so what this means is that we have a 4th root of 81, all raised to the 3 power, okay? And so the 4th root of 81 is no more than 3 to the 4th power. Okay, so what's happening here? 3 times 3 is 9, times 3 times 3 again, which is another 9. 9 times 9 is 81, and that's where that 3 to the 4th comes in, okay? And so the 4th root and the 4 cancel out, and so we have 3 to the 3rd power, which is nothing more than 27, and we're done, okay? So I don't know if we have enough time to do one more, but if not, I'll just do this until the end, okay? So negative stays out. I'm going to raise this to the 1/3 power and then put that -4 out to the outside. I'm shoving all the negatives outside and dealing with this on the inside, okay? So negative cube root is 27, raised to the -4th power. This is negative cube root of 3 to the 3rd power, all raised to the 4th power. And so we have -3 raised to the -4th power. This is nothing more than -1 over 3 to the 4th. And then that turns out to be -1 over 81, and done. Okay, so we're going to finish up right there. If you have any other questions before we leave, please text me or on the chat thing, or email me. If there's any questions, I'm just going to sit here until this for a couple of minutes till you can kind of finish writing down whatever you're writing down. And don't forget to send it in when you can. No rush. Not in a hurry. The world's slowed down. I'm slowed down. I'm not going to cry if it's a day or two late. All right. So, all right. We'll see you tomorrow.